In the previous video, we looked at the char and also the Boolean types, which were Java's 7th and 8th data types. So at this point, you should be familiar with all 8 of Java's primitives. You've seen a similar slide before, and we'll show it again here. So, in review, the 8 primitive types that we worked on previously were the byte, the short, the int, the long, the float, the double, the char, and the Boolean. Each of these primitive types, as we've discussed in previous videos, has got its own size and is used for different purposes. So the byte, as we found out, can only hold a number in the range of -128 to +127. It's entirely possible that you'll go for years as a Java developer and not even need to use the byte ever. But if, as the person writing the program, you know that a byte will fit your purpose, you can use it as a data type to increase the memory efficiency of the code you are writing. The most common primitive types you'll use will be an int, a double, and a Boolean, and you'll probably from time to time need to use a long and a char, but not as often. The short, float, and byte data types are rarely used, if at all. As you get more experienced in Java, you'll learn to use the right primitive type for a given computing problem, and that's actually all part of becoming a programmer. So just to reiterate, those are the 8 data types we've looked at, all primitive types built into the Java programming language. As we go through the course further, you'll find that there's a way to create your own data types, which in Java are called classes. This slide demonstrates that most Java programs use some combination of the data types shown in this diagram. You'll use Java's primitive data types, Java's built-in classes, and probably some combination of your own custom classes and somebody else's. You've already been introduced briefly to a few of Java's built-in classes. These were the wrapper classes, and you may remember we mentioned Big Decimal as a better alternative to floating point primitives when working with currency. We've also said that classes are special data types that can provide extra functionality, like the wrapper classes that contain more information than a simple primitive type. What's interesting about classes is that you can combine data types like maybe one or more ints, doubles, booleans, etc., and create a sort of super data type, which again are called classes in Java. There's an entire section in this course on classes, so I'm not going to go into more detail about them here, except as it relates to the next type on our list, the string. The string is a data type in Java which is not a primitive type, as this slide clearly shows. It's actually a class, but it enjoys a bit of favoritism in Java to make it easier to use than a regular class. In other words, it's treated a little bit differently, and you can use it in ways you wouldn't normally for most other classes. So what is a string? A string is a class that contains a sequence of characters. If you recall, in the case of the char primitive type, it can contain only a single character, either a regular character or a Unicode character. A string, on the other hand, can contain a whole set of characters, in fact a large number of characters. It's technically only limited by the amount of memory space or heap space in your computer, which turns out to be the max underscore value of an int. And if you recall, when we were looking at ints, that maximum size is around 2.14 billion. So that's a heck of a lot of characters that could potentially fit in a string. Let's jump back into JShell and take a look. We will define a variable of type string. String, my string, equals, double quotes, this is a string, semicolon. As you can see, a string is very much like a primitive type in terms of how we use it, meaning we can just assign a string literal to a variable. Now let's go ahead and print out our new string variable. But let's preface the string with a little descriptive message. System.out.print, opening parentheses, double quotes, my string is equal to, plus, my string, closing parentheses, semicolon. So here you can see we can also output a string literal and a string variable automatically by using the plus operator. In fact, you may remember we did something similar when printing string literals and other variables in one statement. You can also do something similar using the plus operator when assigning an expression to a string variable, so let's do that now. My string equals my string plus double quotes, comma, and this is more, semicolon. Let's print that out again by scrolling back through our JShell history and using the system.out.print statement we used previously. You can see that by using the plus operator, we get a result that is the original string plus the text we specified after the plus sign. When the plus operator follows a string, it technically is called the concatenation operator, because the text that follows it is concatenated to the previous text and returned as a result of that operation. And we can see from the output that my string is now equal to the full text. This is a string and this is more. You can also use Unicode characters with strings. By looking up the Unicode character for a $sign on the unicodetable.com site we showed you earlier, I hope you'll understand how we retrieved the Unicode value of 0024. So let's test this out and add a $sign that way. Let's just set our string to a new value as we'll do here. My string equals double quotes, I wish I had backslash 00241, comma, 000, comma, 000.00, semicolon. And the output says, I wish I had $1 million. We could have simply put the $sign character in place of the Unicode value, but there are times when symbols aren't available on your keyboard and you'll want to look up the Unicode value using them this way. This string looked a bit confusing because it was hard to see where the Unicode value ended and the numeric value, 1 million, started. I did it this way because I didn't want a space between the $sign and the dollar amount. So you can see that string has got some versatility. We can use a combination of Unicode characters and regular characters. Unlike the chart data type, we can actually have a significant amount of characters if we like. Alright, let's try something different now. There is a way in JShell to run a couple of lines of code, multiple statements all at once, without declaring them on the same line. To execute multiple lines of code as a set, in JShell, first start with an opening curly brace and press enter. JShell will display an alternate prompt as you can see. You can add a statement and press enter until you've added as many statements as you want to run. Finally, add the closing curly brace, noting that a semicolon is not required after this brace. Once you press enter after the closing brace, all of your statements will run in the order you put them. So let's do that here. First, we enter a single left curly brace and press enter. This tells JShell we want to execute a few statements together and will display the ... greater than prompt we just discussed. String, number string, equals, double quotes, 250.55, semicolon. Number string equals, number string, plus, double quotes, 49.45, semicolon. We'll output the result with system.out.print, number string. So pausing here, we can see we created 3 statements, each ending in a semicolon. When we do finally type in the closing curly brace, these 3 statements will be executed in order. This is similar to typing them on the same line, but when we execute code this way, JShell won't print the value out of each statement. Instead, it just prints whatever we put in system.out.print statements. Before we add the closing brace and execute it, what do you think the result will be? Will the 2 numbers be added together? In other words, if our math is correct and we are adding 150.55 and 49.45, the result should be 300. What do you think? Will we see 300 in the output? So let's find out. We'll run these statements next by using the right curly brace. The right curly brace ends this group of 3 statements and executes them, so let's press enter and see what we get. Now we see that, in fact, we don't get the number 300 at all. Instead, we've got the 250.55, and after that we've got 49.95. Before we talk about why that's the result, let's just do the same thing, execute those 3 statements, but on a single line in JShell. We are typing the same 3 statements as before, but on a single line in JShell, and then we'll press enter. So we got the final system.out.print statement with the same result, but you'll see, as we've seen in all the videos to date, that the variable values were output for the first 2 statements. This is behavior that is specific to JShell. There are 2 ways to execute multiple statements in JShell. Put your statements on a single line, or enclose your statements in a set of curly braces. This shows 2 ways to execute multiple statements in JShell, both ultimately give you the same result. But if you want each statement to output its value, then list them on the same line in JShell. If you want to emulate a Java program, which will only print what you put in the system.out.print statements, then group your statements between beginning and ending braces. Okay, so that's another JShell hint for you, but let's talk about this weird and unexpected result. So what exactly happened here? Well, in fact, technically, the 49.95 was added to 250.55, but it was added as a string. It was concatenated, in other words, in the same way we saw previously with the text strings we looked at. Now the reason for that is that we're not using a numeric type, such as an int or a long, etc., or even a double for that matter. We're using a text data type, a string in this case, and a string treats the text or digits in the double quotes as text and only text. In general, when you type something inside double quotes, Java by default interprets that to be a string literal. So there's no numerical calculations done. We'll need to convert that to another type or save it in another type in order to be able to perform mathematical calculations to numbers in a string. In fact, let's look at this in a slightly different way. Let's declare a new int, but we will add a little twist to it. Int myint equals double quotes 10 semicolon. In this case, you can see that while we're declaring an int variable here, we put the value 10 in double quotes. Java interprets that as a string and throws an error similar to some of the errors we've seen in the past regarding data type incompatibility. Later in the course, I'll show you how you can convert what you think is a number from a string to a number data type. But for now, anything you type into a string is a string, and you can see it's treated differently to the numeric data types that we saw previously. Alright, there is another thing I want to show you that might surprise you. Let's declare a couple more variables, one string and one int. String last string equals double quotes 10 semicolon int myint equals 50 semicolon. So we have two new variables, one a string and the other an int. Now let's try to add those two new variables together. Last string equals last string plus myint semicolon. Notice that what we are actually adding is a numeric data type of int to a string. What do you think is going to happen when this is executed? What output are we going to see? Or do you think this is going to cause a Java error? Let's execute it and see what we get. You can see there that last string is now equal to 1050. So even though we've used an integer data type now, in the second part of the expression, we've still ended up concatenating the integer to the string value 10. Our string variable, last string, is still configured and set up as a string. In Java, the plus symbol is an operator which can mean addition if used for numbers. But it also means concatenation when applied to the string. A string plus anything else gives us a string as a result, concatenating anything after the string as text to the initial string. So keeping that in mind and looking again at our code, Java is smart enough here to say, okay, I know that the integer you've defined, myint, is actually an integer. But I also know that you're trying to add it to a string, and of course last string was in fact declared as a string. What Java does in this case is it actually looks at the contents of myint and converts the value, 50 in this case, to a string. And then this is concatenated to the string value 10. And that's why we're seeing 1050 as the value of our last string. So myint isn't treated as a number in the true sense, rather it's treated purely as text by the computer here because it knows it's being added to the string last string. So the myint variable itself is still an integer variable with an integer value, but because it's being added to a string, the value is treated as a string. And we can continue on with this example. Let's do something similar with a double. Double number equals 120.47 semicolon last string equals last string plus double number semicolon. You can see here last string is now equal to 1050 but also with the 120.47, which was the decimal version from our double data type. So the behavior was exactly the same as when we used an integer. Java's treated the double value as text and appended that as text to our string variable. What we're doing here is only a very elementary way of dealing with strings and adding to strings. In later lessons, we're going to look at more advanced features of a string because we can do all sorts of things with string. Using strings and manipulating strings will be something you do in every program you write, so the string class and its features are important to know. A string is different from many other classes because the sequence of characters in the string are immutable. What does this mean? Immutable means that you can't change a string after it's created. So in the case of the code we've written, the value 120.47 is technically not appended to the current contents of last string. Instead, a new string is created automatically by Java. The new string consists of the previous value of last string plus a textual representation of the double value 120.47. The net result is that our variable last string has the concatenated value. However, Java created a new string in the process, and the old one will get discarded from memory automatically. Now, don't worry if that makes no sense at this time. It will later in the course. For now, I just wanted to point out that strings are immutable, and that will make more sense and become more important as we progress. Because of this, the code that we just wrote there was quite inefficient. Because a new string gets created for every operation, appending values like this is inefficient and generally not recommended. Java provides another class that is more efficient if you are doing a lot of appending of multiple strings or values. The string class is immutable, but can be used much like a primitive data type. The string builder class is mutable, but does not share the string's special features, such as being able to assign it a string literal or use the plus operator on it. Both are classes, but the string class is in a special category in the Java language. Java provides a class in its library to address the inefficiency of the immutable string when you are creating a large amount of text from many smaller parts. This class is called the string builder class. Unlike a string, the sequence of characters in a string builder class can be changed. We'll be revisiting the string and the string builder classes in much greater detail after we develop a better understanding of how classes work in Java. But I've also shown you the string concatenation operator today because you'll come across code written in the style we've used in this lecture. Using operators like plus to concatenate string values is code you'll probably see. It's useful for you to know how to do things this way, but it's also important to understand there's a better way to do it, so stay tuned for more on strings and string builders in future videos. The string is so intrinsic to the Java language it can be used like a ninth primitive type. But it's not a primitive type at all, it's a class. From your point of view, you can treat the string like a ninth primitive type by directly assigning a string literal to it and using the plus operators with it. The Java language set the string to be used in a simpler fashion compared to traditional classes, which we haven't covered yet. You'll be using a lot of strings as we progress through the course and in general in your working life as a Java programmer. The plus sign and other mathematical symbols like the minus, multiplication, and division signs are examples of operators which we've only briefly mentioned so far. We're now going to look at operators in more detail, so let's move on to that next video now.